Welcome, lecture E9, polymers, another one in the field of materials. And in this environment, we have the normal setup for the lectures in materials, which start with introduction, classification of material polymers, in this respect, production and the application of the material. Introduction, plastic or polymers is a relatively new type of construction material. It starts somewhere in the 1950s as a result of World War ending and the need of new materials and say the technical understanding of how to produce these material. And it's now used in a wide range of functions in construction. Obviously, windows, facades, that's what this seems mainly about as well. Here we see a typical 1950s, 60s modular construction idea made out of a polymer. So the plastic forms as precasted forms in which you mold the geometry, the components of the building, and then assemble them as prefab construction systems. Quite nicely designed at that time, but also this one, which is a lightweight structure, idea of lightweight structure, idea of transparency, the Freie Otto Olympic Stadium 1972-3, which is entirely covered with polycarbonate, and by this helped to have an entire new architectural experience, which is what the materials stood for at that time. Today, plastic are used for a lot of cladding functions, same as plumbing and as other fittings, but with polymers, main difficulty is aging. So interior fitting, we may have 10 years use. So window and frames, we have 25 years of use. You're all aware of the PVC windows, which are start rotting because they're getting old. And building structure, we have a time of 50 to 100 years to be used. And in that respect, polymers tend to have difficulties because they don't last that long as construction material. Classification, which is one of the most important things you need to understand in this respect. We do deal with thermoplastics, which are melting when boiled. So you have a granulate, you boil it, it starts to melt, and by being heated up and then melting, it's possible to somehow form it, versus the thermosetting plastics, the duroplasts, which are brought together as components, then set and harden, and do not melt when reheated, which means we can use them in different functions where we have, say, risk of overheating, for example. Due to the temperature aspect, the thermoplastic are not that much used for real structural components in our environment. Classification still of plastics, polycarbonate, acrylic, and PCVU, polyvinylchloride, which we explain in a second. You see there's a certain wide range of tensile strengths, compressive strengths, Young modules, which can be seen when we go to the different materials itself. For example, the polycarbonate, a thermoplastic polycarbonate, it's generally used as, say, a substitute for glass, large spaces, large areas to be filled. It has a high strength, it's ductile, it's light, and can be transparent or translucent. It's easily molded into complex shapes. It's easy to be extruded. We see later a sample of an extruded one. It has a certain impact resistance, which is close to glass. It's less durable than glass, and always a point with plastics, polymers. It's not scratch resistant. So as a surface in a long function, that's something which could be discussed. Same direction, acrylic sheet. Perspex as a product name of the 1930s, high tensile strength and compressive strength, so quite solid. It's actually hard, it's brittle. It has a good resistance against yellowing, which is the difference to the one before. Yellowing means the material itself starts to get yellow by a certain lifespan, 10 years, 15 years later, which is not the case with acrylic sheets, and that's where it is used as a frequent replacement for glass, due to its durability, due to its strength. Again, it has a very poor resistance against stretches. And then we come to the PVCU, the polyvinyl chloride plasticized. Plasticized means that there's a supplement brought into the PVC which stops it to soften, which means that you're dealing with a PVC which on a longer term stays in the structural performance as it is supposed to be. It's easy to be molded, it's easy to be extruded, so complex shapes are something which are frequently used. It has a wide range of different colors. It cannot be transparent, but it has a wide range of colors. It has a low thermal conductivity and is at a certain flexibility, which allows it to be used in window frames due to reduction of thermal exchange inside outside. So it does not need a thermal break in a facade, for example, as we know this from steel and aluminium. As a setting. Typical uses, polycarbonate and acrylic, more a sheet-like material, which we use polycarbonate being a lot cheaper, but then having the problem of the yellowing by age. Acrylic being a bit more expensive, a bit harder, a bit more complex to shape. And the PVC to be extruded, which we see in a second. The production typologies of polymers, we deal with polycarbonate, with acrylic, and with PVC. Polycarbonate is a thermoplast and can be, for example, large sheets folded, so heated up and then folded and brought into form. Acrylic is mainly extruded, sometimes molded or cast. And PVC is mainly extruded to make complex sections, for example, for windows and doors, which we see in a second. This is such an extrusion device. So the extruder itself, you fill in the granulate at the top, then you heat the granulate in this extruder by turning the screw. This whole thing is moved to its nozzle, and then the extrusion process happens as at the nozzle. This is such an extrusion process. You see the tank with the granulate, it's brought into the extruder. This is the extruder, this left device. And then you see the nozzle, which has this certain shape, which is already a profiled shape for extruding a certain facade component. This is how it ends as an infinite extrusion result. And this infinite extrusion result needs to be cut at typical length is 6 meters, and then it's cut in parts. And then we see this extrusion components of a PVC window. And you see it's two parts, and this is the one part, and then the other part which is attached to it. And then there will be later, which is happening here, or which we see in a second, melted together. The injection molding, same process, having this extruder which heats up the granulate, and then the polymer is brought into a mold, and then filling this mold. If it's then filled, cooled down, the mold is opened. That's what you see with this screw to keep it closed. And then you have the object. That's a solid object. If you want to have a hollow object, you go for extrusion blow molding, which means you have a tube which is brought into a mold. Then into the tube, air pressure pushes the surface of the tube to the mold to create the shape. Then the mold is open, and then you have the shape as a system. Standard water bottles in plastic are made like this. If you tilt them and you look at the bottom, you find this nozzle where this extrusion blow molding starts. And then vacuum forming gives us a good opportunity to create nice shapes, a lot done with the polycarbonate or with the acrylic surfaces. You heat up the thermoplast, you bring it in position, you place it on top of a mold, then you evacuate the volume, the space below. By that you suck the surface on top of this mold. That's what you see here. And then you decast it, take off the result, and then have the shape as you want it. Compressing molding means if you have one mold, the other mold pumps into it. You have to have the granulate inside, and then you shape it to the geometry you want. You have to take care of that. Say the angles always allow you to take the result, the component you want to get out of this mold. Otherwise it's stuck, and then you're not able to get your result as you wanted it. Application for polymers. Most polymers are used for windows or interior fitting. That's where we see this mainly. The reason for that, it's a low cost, it has a low thermal conductivity, so it's simple to use, simple to make, and simple to use. There are some subparts, the glass reinforced polymers, GRPs, which we are aware of, but that's a composition of glass fibers and polyester epoxy as structure. Not that much used currently in our facade environment. This is a production of a PVC frame. You see the PVC frame in its finish. That's how it is done. We see the two parts vertical, two parts horizontal, brought in position. Then there's this iron, which is between the two window frames, brought in position. It heats up the surface of the two window frames. Then it's taken out, and then the two window frames are brought together. That's what this machine does. It just pumps the whole thing together. And with that, heated up, pre-melted, this whole thing is kind of welded together as a window frame setting. This is the typical section of such a frame. So we see the extruded profile, we see the bottom profile, we see the top profile, maybe some infills if necessary for structural reasons. And then, as just shown, the frames are melted together in the corners to allow this structure. And here we have some polycarbonate cladding as said, and this is can be extruded as well. So the polycarbonate profiles extruded and then brought into the facade as a cladding, dealing with the barrier inside, outside, as well as the thermal aspects. As usual, this is part of the Delft and Darmstadt Munich Facade Education Project, and all the members who participated in developing it. And by this, I end this session.